Hey guys, what's up people? How are you guys doing? Welcome back to today's session. Once again, hoping that you guys are doing good and taking very good care of yourself. Welcome back. So not too long ago, we had done the second session of work, energy and power. This is going to be the third session. So welcome back. My name is Anoop. I'm Master Teacher of Science here at Vedantu. Once again, welcome. So we will let us understand about potential energy, and also we'll try to solve some numericals based on potential energy as well. That is what we're going to be focusing on in today's session. So without any further ado, as always, let's start with the quote and then get on with the topic for today. The quote for today is this, guys: if you're positive, you'll see opportunities instead of obstacles. And that is something that you should start practicing. It's not something that will come in one day, but yes, guys, the more you look at anything as an opportunity than an obstacle, you would feel like things would get a lot more easier. You would feel like everything is going your way. You would take everything as a challenge rather than as a burden, which is something something that you really don't want to do. So that's it, guys. Let us get into today's session, which is nothing but potential energy and its numericals. So in the last session, I'd given you homework as always, and the homework for this, guys: a man exerts a force of 200 newton in pulling a cart at a constant speed of 16 meter per second. Calculate the power spent by the man. You're supposed to calculate the power spent. They've given you the force, they've given you the speed as well. Find out what is the power spent by the man. So you know the formula. We saw that power is nothing but work done by time. I told you that work done is nothing but force into displacement by time, and displacement by time can be written as force into velocity. So we can indirectly you can say that power is nothing but force into velocity. So here they're giving you the speed. Now here's the thing, guys: because the object is going at constant speed, we can assume that, let's assume that the direction is also constant. So if the speed is constant and the direction is also constant, then you can say that the body is moving at uniform velocity as well. So you can say that the body is moving at constant velocity. So with that said, you can substitute in place of v, you can substitute 16, because why? We are assuming that the direction is also constant, and the speed anyways is constant. So when you consider the direction as well, it'll be constant velocity. So 16 into what is the force, 200, if you multiply it, you will get the answer as 3200 watt. That's always very simple question. It's just that they've given you the speed. Just consider that to be the velocity, because you're assuming that the direction is constant because it's being pulled. They've not mentioned about any change in direction, so you can just directly take that to be the velocity as well. Now that you understand this, guys, let's move on and do the topic for today. So here's the thing, guys. Let's consider a very simple example. Imagine there's a rock which is kept at a wall of a height h. All right. Let's say that the rock rolls down and falls on the ground. So yes, guys, is there any work done by that particular rock? Absolutely yes, there is some work done. For sure, there is some work done, and that is the reason why it is getting displaced from a certain height. And that if there is some kind of displacement happening, obviously, or if there's some kind of work done, that means that the object should have some sort of energy as well, right? We've seen that in the last session, that energy is nothing but the capacity to do work. So if there's no energy, there'll be no work done. Because there is work done, there is some sort of energy as well. Now, the energy possessed by the ball in this situation is what is called as mechanical energy. Now, what is mechanical energy? Is nothing but the energy possessed by a body by the virtue of its state of rest or motion is what is called as mechanical energy. So you have two kinds of mechanical energy: potential energy and kinetic energy, which we'll be studying about later on. Today, our focus is going to be on understanding about the first kind, which is nothing but potential energy. All right, now that you've understood this, guys, let's come back to the example. So when the ball or when that rock was in the state of rest, do you think that it had some sort of energy? Absolutely. Only because it had some energy, it rolled down and fell down. If it did not have any energy, then it wouldn't move at all. That means there'll be no work done at all. Because it has some energy, it does start moving or rolling down, and it falls down onto the floor. Now, the energy that is possessed by a body by the virtue of its state of rest or its position, that is called as potential energy. The energy possessed by a body when it's in the state of rest, or by the shape or by the size of the object, that is what is called as potential energy. So What do I mean by size and shape? We'll talk about it in a minute. For now, understand this, guys. When a body is in the state of rest, it does have some energy. It's not that your energy, it does not mean that the object does not have energy at all. And that energy possessed by the body when it's in the state of rest, that is what is called as potential energy. Simple as that. Now, we know that our Earth is pulling everything towards its center by the force which is called as gravitational force. You already know about it because obviously Earth has some mass, and because it has some mass, it attracts every other object which has mass, which is what is called as gravitational force. Now, a potential energy of a body at a certain height, like in the case of the ball of the rock, when you had kept it at a certain height, it's at a certain height from the ground, right? So the energy possessed by a body, because of its position with respect to the ground or with respect to the earth, that is called as gravitational potential energy. The potential energy associated with the height of the position of the object with respect to the height of the ground, the height from the ground or the distance from the ground, that is what is called as gravitational potential energy. So what is gravitational potential energy? The energy possessed by the body relative to the position from the center of the earth, that is what is called as gravitational potential energy. So from the center of the earth, what is the distance of that object? That is what is called as gravitational potential energy. Now let's try to understand how do we derive, or how do we find out what is this gravitational potential energy. So let's take an example, guys. Let's say there's a ball and it's kept at a certain height, all right? And the mass of the ball is m. Let's say the mass of the ball is m, and it's kept at a certain height h. Very simple. Now the ball did not just fall right there, right? It did not just fall from the sky and landed on it. So it was initially in the ground. You lifted it up to a certain height and kept it on that place. So let's say that the potential energy on the ground, at the ground itself, is zero. So potential energy, which is denoted as U, let's say that it is zero. When it's on the ground, let's say the potential energy is zero. Now, when you're lifting it up to a certain height, you're doing some work done, right? You're doing some work done. So work done is, there is some sort of work done. Now, in this case, what is the potential energy? Potential energy is nothing but the work done, right? The potential energy is nothing but the work done. Now, what is work done? Work done is what? Force into displacement. Work is nothing but force into displacement. What is displacement in this case? You're taking it up a certain height, so displacement is h, right? You found out that the potential energy, you want to find out what is the potential energy of that particular ball. So you're spending some energy to lift that ball up and putting it up on a certain height, which is a height h. So the ball now has some sort of potential energy. You want to find out what is the potential, what is the value of that potential energy inside that ball. So what is U? U is nothing but potential energy, which is nothing but the work done, because you're spending some energy to lift it up and keep it on top of that that raised platform. So that is nothing but F into S. S is nothing but the displacement, which is nothing but h in this case. Now, what is the force required? See, guys, to lift up this ball, you are doing some work against gravity, right? You're going against gravity. So there is a force acting on this ball because of gravity, which is called as the weight. The weight is nothing but the force by which anything is pulled towards the center. That is nothing but the weight. So you have to apply a force at least equal to the weight of the, you can apply more force than that, but at least minimum, you have to, you have to, you have to match the weight of the object so as to lift it up and keep it on a certain height. So the force that you're going to put, or the force that you're going to apply, is nothing but the weight of the object. Now, what is weight of the object? Weight is nothing but mass into acceleration into gravity. Substitute that over here. So what are you going to get? Weight is, U is equal to, one second guys, so I took the highlighter, sorry about that. So what is the potential energy? Potential energy is equal to m into g into h. After you substitute this, the value of w in place of this. That is, see guys, this w is nothing but the work done. Here is nothing, this is the weight. W, the small w, is nothing but the weight. Simple as that. So that's how you find out what is the value of that potential energy. So the formula to find out potential energy is this, guys. U is equal to, that is, at a body at a certain height, is U is equal to m into g into h, where m is the mass, g is the acceleration due to gravity, and h is nothing but the height or that particular displacement, the height at which the object is moved. As simple as that. That's all, guys. Now, let's say this that you are lifting up, you're lifting it up to a certain height, even more higher than that. What you have to understand is, guys, mathematically also, if you just think about the equation, we have just found u is equal to m into g into h, right? Or mgh. If height is going to be more, then the potential energy is going to be also going to be more. It's directly proportional. So the more height you take the object to, the more the potential energy that the body would possess. As simple as that. So how do you find, what is the conclusion that you can come to? The work done in lifting up the body, which is stored, and it is stored, the work done to lift up the body, and the energy stored inside it is what is called as gravitational potential energy. And how do you calculate it? It is nothing but u is equal to mgh. As simple as that. And again, as you increase the height, the potential energy also increases. So if you were to compare these two cases, where there are two elephants, one is standing on the ground and other at a raised platform, this would have a higher potential energy compared to this. This will have a lower potential energy because the height from the ground is more in the case of the first elephant. As simple as that. Now that you've understood this, guys, let's understand one more simple example. So let's say this, guys. Let's say that you did some work to lift up the ball and put it on this pedestal or this height, and then again you did some work to pull it from here to here. All right, so to move from here to here, that is height h2. You've done some work as well. Now suppose I want to find out what is the gain in potential energy from this height to this height. What is the gain in potential energy? How do I go about it? So gain in potential energy is nothing but, guys, final potential energy minus the final potential energy at this point minus what is the initial potential energy at this point. You will get what is the gain in potential energy, or the difference in potential energy that you have to do, the work that you have to do to pull it up and keep it on that particular height. So how do you calculate it? Now potential energy at this height is what? mgh. Now it will be mgh1 because the height is h1. Sorry, this is the final potential energy, so mgh2, final minus initial, minus mgh1. Now mg is common, mass is going to be the same. The acceleration to gravity does not depend on the object. It depends only from, it differs from one place to another. So because it's in the same place, acceleration to gravity would also be the same. So you can say that mg is constant, so it will be h2 minus h1. So gain in potential energy, you can find it by using the formula mg h1 minus h2, where h2 is the final height, h1 is the initial height. Simple as that. Now that you understand this, guys, let's take another example. Let's take a spring this time, right? Let's say that you have a spring. Now, what do you do generally when you have a spring? You stretch it from both sides. So when you're stretching the spring from both the sides, you're doing some work. You have to do some work to pull it up. So whatever work, so that means you're spending some energy. So whatever work done is done, and whatever is the work done to stretch that spring, to keep it in that position, you are doing some work. So there is some sort of energy stored over there as well, and that energy is called as the elastic potential energy. The energy stored when, because of its position, or if it's because of its the shape of the material, that is what is called as elastic potential energy. Now another example for elastic potential energy is a bow and arrow. So when an archer pulls the bow towards him, you see that he's pulling the string. So when he's pulling the string, there is the potential energy on the bow is actually increasing. The potential energy on the bow is actually increasing, and on the string as well, it's increasing because of its position. And as soon as you leave it, what happens? The potential energy gets converted to kinetic energy and the arrow starts moving forward. So yes, guys, here also you can say that it is because of elastic potential energy that the arrow starts moving forward. As simple as that. So in conclusion, guys, potential energy possessed by the body due to the force of attraction of the earth is what is called as gravitational potential energy, which is represented as U. U is equal to mgh, and the SI unit is joules. And the potential energy possessed by the body because of its shape, the deformed shape or the size, is called as elastic potential energy, like in the case of bow and arrow as well as the spring. Simple as that. Alright, now that you've understood all of these, guys, let's do some questions. But before that, let me take 2 minutes of your time and tell you something very, very important. That is something that would definitely help you guys out. So when we did this survey, we had done a survey recently, and there are a lot of problems that you guys came up with, especially during this pandemic time. You know, a lot of problems that you were facing, and I'm pretty sure that every one of you guys would be able to relate to this. One is that, sir, my doubts are not getting cleared. My notes, I'm getting notes, but it's not enough. Tests and assignments. How do I test myself? How do I make myself better? And how do I train myself for competitive exams? All kind of competitive exams. Your choice of your own schedule, because I'm free at a certain time, but the teacher is not available at that time. That is also another important problem. And finally, the choice of your own language, because language is a very big barrier, especially in India right now, because there are a lot of regional languages, and not many of us are comfortable with all the languages that we have. Now, here's the thing, guys. These are all the problems that you're facing. I'm pretty sure that you have ton more problems apart from this, but I'm pretty sure that you would be able to relate to all of these problems as well. Now, at Vedantu, guys, we have solved all of these problems. Now, how do we solve all of these problems? That doubts inside the class, you'll have a two-teacher model. You'll have a master teacher as well as a class teacher. So the master teacher will be teaching the concepts and clearing your doubts. At the same time, you'll also have a class teacher to clear your doubts as well. So you are getting a personalized attention, making sure that your doubts are cleared in the class itself. You'll get you can download the notes as many number of times that you want. Whatever is written on the whiteboard, you can download that as many number of times that you want. Tests and assignments, you have periodic tests and assignments, so you can check yourself where you're at. You can compare yourself with the entire country as well. You'll be having those kind of tests to check where you're really at in terms of the entire country. And you'll have free coaching for your competitive exams as well, so that you get you can improve yourself in other aspects as well. You can choose your own schedule and a language of your choice. Now, at the moment, we are offering Hindi and English, not the regional languages, but I'm pretty sure that everyone would be like, the entire country is divided as Hindi and English. So, I mean, not per se, but then yeah, majority of them do understand it. So that's how we are going about it right now. So apart from all of these guys, you'll also have unlimited live classes. You can attend how many number of classes that you want. You'll have all micro courses and crash courses for free. You'll have a performance report card to tell you where you're going wrong. So whatever tests and assignments you take, you'll get a detailed report card of that as well. And like I told you, you get personalized attention. So what you have to do is this, guys. Visit this website, vdnt.in/ytpro. You can take a screenshot of this if you want. Visit this website. As soon as you click on this, they'll take you. This is the first page that you're going to see. You're going to choose which grade are you in. There are 1 to 12 grades, so you can choose between 1 to 12 grade. We are offering courses from 1 to 12 grade. Let's say that you're someone who's in 10th grade, and as soon as you click on that, you'll get an option to choose your board. Are you in CBSE, ICSE, or Maharashtra? For now, we are only offering these three boards, but later on we'll be adding more to that as well. So let's say that you're someone in CBSE syllabus, you're doing CBSE syllabus. Then as soon as you click on it, this is what you're going to get. What and all, I just told you everything in one glance. What you do is basically click on get subscription. Once you click on get subscription, you'll get this page where it says 1 month, 3 month, and 6 month course. So let me just tell you that in a little bit detail, guys. So 1 month course, let's say for the next 30 days you want to try it out. The base price is 4,000 rupees. But without any kind of discount, coupon, or anything for that matter, a primary discount is automatically applied, which brings the price down to 2,699 rupees. And if you use the coupon code AKPRO, you'll get another additional 400 rupees discount. Essentially, you'll be paying 2,294 rupees. From 4,000 to 2,294 rupees. And let's say that you're going for the 3-month subscription. The base price is 10,000 rupees, but again, a primary discount is already added to it, so you'll have to be paying 6,999 rupees. And if you want a further discount on that, use the coupon code AKPRO. You'll get another 1,449 rupees discount, essentially paying 5,949 rupees. And let's say that you want to go for the 6-month course, so the base price is 16,000 rupees. Again, you get a primary discount of 11,499 rupees. And if you use the coupon code AKPRO once again, you'll get another 1,700 rupees discount, making the price to be 9,774 rupees. As simple as that. Do check out the link and let me know what you think about it. It's once again, guys, this is the website. It's vdnt.in/ytpro. Again, if you like all the problems like I just told you, everything is solved over here. So do try it out. Let me know what you think about it. With that said, guys, let us get back to the topic. Now let us solve some questions and get to see, just try to understand how much of us have really understood the concepts. Now again, guys, I want you guys to write down the answers in the comment section below. Let me know what is the answers for these questions. So first question. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meters above the ground, given that acceleration to gravity is 9.8 meter per second square. So you're supposed to calculate what is the the potential energy in this case. Mass is given, height is given, acceleration to gravity is also given. Find out the answer, guys. It's a very simple question. The U is equal to, what is that, mgh. What is m? M is 10, height is 6 into 9.8. So that's 98 into 6. What is 98 into 6? 8, 5, 5, 6, 48, 8, 4 carry, 9, 5, 45, 9, 6. Yeah, the 50, 50, 54, 58. So you'll get it as 588 joules. Simple, guys. Calculation here and there, but yeah, the right answer is 588 joules. That is the answer for that question, guys. Moving on to the second question. Here's the second one, guys. An object of mass 40 kg is raised to a height of 5 meters above the ground, and its potential energy is what? 200 joules, 20 joules, 2000 joules, or 20,000 joules. Let me know what is the answer in the comment section below, and I'll try to solve it for you guys. So your mass is given. Mass is given as 40 kg. Height is given as 5 meter. Just for the ease, I'll take acceleration to gravity as 10 meter per second square. Put it on the equation, mgh, u is equal to mgh. So m is 40, 5 and 10. That's 400 into 5, 420. So that's 2000 joules. That is the answer, guys. Very simple question. That is the answer for that second question as well. 2000 joules. Moving on to the third question. Here's the third one. A boy weighing 25 kgf climbs up the first floor at height 3 meters above the ground to the third floor at height 9 meters above the ground. What is the increase in the gravitational potential energy? Is it 2000 joules, 3000 joules, 1800 joules, or 1500 joules? Now, you can directly use the formula for this one. What is the formula? I just told you U is equal to what? mgh2 minus h1. What is m? 25. What is g? I'll take it as 10. What is h2? H2 is 9 meters. H1 is 3 meters. So that's 250 into 6. So how much is 250 into 6? 250 into 6. 33, 3 to 6, 8. So 1800 joules. That's all, guys. That'll be the answer for this question. Sorry, did I make any calculation mistake? 5, 33, 12. Okay, yeah. Nah, 12 plus 3, right? It's 15. Sorry, guys. Simple calculation mistake. So yeah, you'll get the answer as 15,000 or 1,500 joules. As simple as that. That is the answer, guys. With that said, as always, the homework for today is this. Do let me know what is the answer in the comment section below. The homework is this, guys. When you're stretching a rubber band, you are storing dash energy into it. Specifically, what energy are you storing when you're stretching up a rubber band? Let me know what is the answer in the comment section below. Thank you for joining, guys. That is it from my side. I hope you enjoyed today's session. I hope you learned something new out of today's session. See you all in the next one. If you did like the session, leave a like, subscribe to the channel, and be aware of what and all topics are going to come up next, because you have some amazing teachers over here. Chemistry, biology, math, English, all super awesome teachers are there. So enjoy from the best of the best. Thank you for joining. See you all in the next one. Take care of yourself. Stay safe, guys.